Basic terms and definitions. We know that a part or portion of a line with two endpoints is called a line segment. The line segment AB is denoted by this symbol. A part of a line with one endpoint is called a ray. The ray AB is denoted by this symbol. And the line is denoted by this symbol. We also know that if three or more points lie on the same line, they are called collinear points. Here A, G, F are called collinear points. And points B, C and E are called non-collinear points. Now come to an angle. An angle is formed when two rays originate from the same endpoint. The rays making an angle are called the arms of the angle, and the endpoint is called the vertex of the angle. We know about different types of angles like acute angle, right angle, obtuse angle, straight angle, and reflex angle. Let's go through them one by one. When two lines, say AB and CD, intersect each other, say at a point O, then the angles formed are called vertically opposite angles. These are two pairs of vertically opposite angles. One pair is angle AOD and angle BOC, and the other pair is angle AOC and BOD. Another question for you. What do we call those angles which have a common vertex, a common arm, and their non-common arms are on different sides of the common arm? They are called adjacent angles. Here ABD and DBC are adjacent angles. Ray BD is their common arm and point B is their common vertex. Ray BA and ray BC are non-common arms. Also, when two angles are adjacent, then their sum is always equal to the angle formed by the two non-common arms. So we can write angle ABC is equal to angle ABD plus angle DBC. If the non-common arms B and BC form a line, then it will look like this. Then the angles ABD and DBC are called linear pair of angles, pairs of angles. Now let us find out the relation between the angles formed when a ray stands on a line. Look at this figure. Here AB is the line and OC is the ray. Angle AOC, angle BOC and angle AOB are the angles formed at O. Can we write angle AOC plus angle BOC is equal to angle AOB? Yes, because angle AOC and angle BOC are adjacent and angle AOB is the angle formed by the two non-common arms, and we have studied that when two angles are adjacent, then their sum is always equal to the angle formed by the two non-common arms. Mark it as 1. The measure of angle AOB is 180 degree because it is a straight line. Mark it as 2. From 1 and 2 we can say that angle AOC plus angle BOC is equal to 180 degree because angle AOB is 180 degree. This gives an axiom. Let's go through it. Parallel lines and a transversal. Friends, we have studied that a line which intersects two or more lines at distinct points is called a transversal. Look at this figure. Here, line L intersects lines M and N at points P and Q respectively. Therefore, line L is a transversal for lines M and N. Observe that four angles are formed at each of the points P and Q. Let us name these angles as angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. Angle 1, angle 2, angle 7, and angle 8 are called exterior angles, while angle 3, angle 4, angle 5, and angle 6 are called interior angles. We have also studied that when a transversal intersects two lines, we get some pairs of angles. Let's go through them one by one. First is corresponding angles. These are angle 1 and angle 5, angle 2 and angle 6, angle 4 and angle 8, angle 3 and angle 7. Second is alternate interior angles. Those are angle 4 and angle 6, angle 3 and angle 5. Then comes alternate exterior angles, and they are angle 1 and angle 7, angle 2 and angle 8. Next is interior angles on the same side of the transversal. These are angle 4 and angle 5, angle 3 and angle 6. Interior angles on the same side of the transversal are also referred to as consecutive interior angles or allied angles or co-interior angles. Now let us find out the relation between the angles in these pairs when line M is parallel to line L. So, with ruler and pencil, draw two parallel lines along any two of these lines and a transversal to intersect them. Now if we measure any pair of corresponding angles, we find that angle 1 is equal to angle 5, angle 2 is equal to angle 6, angle 4 is equal to angle 8, and angle 3 is equal to angle 7. For this, we get one more axiom, which is If a transversal intersects two parallel lines, then each pair of corresponding angles is equal. If a transversal intersects two parallel lines, then each pair of corresponding angles is equal. This axiom is also referred to as the corresponding angles axiom. Now let us discuss the converse of the axiom. If a transversal intersects two lines such that a pair of corresponding angles is equal, then the two lines are parallel. Does this statement hold true? Let us verify it. Draw a line AD and mark points B and C on it. At B and C, construct angle ABQ and angle BCS equal to each other. Produce QB and SC on the other side of AD to form two lines PQ and RS. We can observe that the two lines do not intersect each other. We can also draw common perpendiculars to the lines PQ and RS at different points and measure their lengths. You'll find it the same everywhere. So we can say that the lines are parallel. Therefore, the converse of corresponding angles axiom is also true. So we have got one more axiom for this, which we will discuss in next screen.